Today we're going to focus on what makes a strong hypothesis. So a lot of people, especially coming from elementary school, when I ask what a hypothesis is, usually the first response is an educated guess, which is technically true, but it's not actually accurate. We're going to be more specific when we're talking about a hypothesis in middle school. We're going to be a lot more specific than that, okay? We talked yesterday about doing observation, doing inferences, being able to find background information, things that we already know about it, doing a little bit of research. All of that leads to a good hypothesis, okay? Now, you'll see in this anchor chart, in the little words right here, hypothesis, ISIS at the end, means one hypothesis. Hypotheses with SES at the end means more than one. So from this point forward, you'll hear me say hypothesis or hypotheses. What it is one of them is singular, the other one is plural. Okay, so it's this talking about the same thing, it's just singular and plural. Okay, so when we're talking about a strong hypothesis, okay, these are the factors that go into a hypothesis being strong. Okay, so it's written as a sentence. Okay, this kind of goes back to our discussion boards too. I say full sentences, it means an actual sentence. It has a subject, it has a verb and things that go along with the verb. The first word is capitalized. There's punctuation at the end. It's not one long run-on sentence for seven lines. You know, it's written as a sentence. Okay, it's something we can test. If I say I'm gonna run an experiment and we're gonna see if the sky's blue. Well, that's really hard to test. Because the sky's blue during the day, but if you run the test at night, the sky's not blue. So it's hard to make that. It's hard to actually test that. It has to be something that we can measure. Okay, there's no way to measure blue. You know, what kind of blue? Well, there's multiple kinds of blue. So it has to be something we can test. It has to be something we can measure. And it's a cause and effect statement. It's an if-then statement, okay? If I do this, then this will happen. Now, sometimes it's written as an if-then statement. Sometimes it's not. Sometimes it's written just as a regular sentence. But it's important to understand for the strong versus weak, you need to have something that you're changing. That's the if, the independent variable. That's the if. Okay, if I write with my left hand, okay, that's the independent variable. A hypothesis always has an independent variable and a dependent variable. We're going to get more into that tomorrow. So if I write with my right hand, then I will write 10 zeros in 15 seconds. If I write with my left hand, I will write 100 zeros in 15 seconds. It's something we can test. I'm using my left hand, I'm using a timer, and I'm counting the number of zeros. Okay? It's something we can test, and it's something we can measure. We can count the number of zeros. That's a measurement. Okay? The independent variable, what's the thing that we're changing? Well, I'm using my right hand, and then I'm going to run the test again and use my left hand. And I'm going to compare the two. So that's the independent variable, what I'm changing, my right hand to my left hand. The dependent variable is what happens because of my changing it. Well, if I'm better with my left hand than I am with my right hand, then I'm going to write more with my left hand than I am with my right hand. So the dependent variable is the number of O's, or the number of zeros that I'm writing. So when we're talking about a strong and a weak hypothesis, we're talking about something that's written as a sentence, something we can test, something we can measure, and that it's an if-then statement. If I do this, then this will happen. So that's the basis of a strong or a weak hypothesis. It's simply, if I do this, then this will happen. Okay, if I say I'm gonna eat chocolate for a week, and when I'm done, it will cause 5 more pimples. Is that a strong hypothesis? Is it something we can test? Is it something we can measure? Is it an if-then statement?
Yeah.
Okay. Yeah, you're right. It is a strong hypothesis. The question then is, if we do it and it doesn't happen, so I eat chocolate for a week and I actually have less pimples than I started with. Now we have to decide, are we going to rewrite the hypothesis again? I'm going to do another test, and this time I'm going to eat chocolate for a week and it's going to cause less pimples, 5 less pimples. And then I run the test again and now I have 5 more pimples, so it doesn't match up again. We have to keep practicing with our hypothesis. It doesn't mean we're right or wrong. Okay, we get in this mindset. There are some things there's a right answer and a wrong answer to. In math class, there's a right answer and there's a wrong answer, right? 2 plus 2 is 4, right? But when we're talking about a hypothesis, we're talking about testing something we're not sure about, so that we can see if it's accurate, if it's right or not. And if it's not right, we just change it and test it again. And then we change it and test it again. If it is right, we may want to run a test again just to make sure it happens again. Most scientists will run a test 3 or 4 times if they get it right, just to see that it's right, just to make sure that it's right every time. That repetitive nature of running the hypothesis over and over again is part of what makes the scientific method important. It helps us to be able to track through, okay, I did this once, I did it exactly this way, I got the answer that matched my hypothesis. So I'm going to do it again, do it exactly the same way, and I got the same answer. So I did that twice. I bet if I do it a third time, I'm going to get the same answer. And then they do it a third time and get the same answer. They know that the hypothesis is right. However, if it's wrong, then we have to change things. Do I change from chocolate to bananas? Do I change from a week to 2 weeks? Do I change 5 pimples to 12 pimples? That's up to the person that's doing the experiment. They're the ones that get to make that adjustment to the hypothesis. But to start, hold on, I see chat open here and I'm okay. But to start, we have to make sure we have a strong hypothesis to begin with. Okay, 3 pieces, 3 big pieces. Can we test it? Can we measure it? Is it an if-then statement? If I do this, then this will happen. Okay, so this is what I would like you to do. For a small group today, these are our, whoops, let me put it back up because you can't see it. Oh, well, you can if you have your Canvas class open, but you can't see it on my screen.